You know, usually when we talk about a software leak, it's like this really passive, almost archaeological event.
Right.
Like someone leaves a digital door unlocked, maybe an S3 bucket is just left public or whatever, and the code spills out onto the internet.
Right. And that's essentially the end of the story.
Exactly. The damage is done, and security researchers just, pick through the ruins.
It's the digital equivalent of a spilled glass of water. It just sits there, completely inert, just waiting to be analyzed.
But then, you wake up on April 1st, 2026, and you realize the fundamental rules of the game have just completely changed.
Oh, absolutely. The landscape is totally unrecognizable today.
Anthropic's massive Claude Codebase, we are talking about over 500,000 lines of pure TypeScript, has leaked.
500,000 lines, yeah.
But this code is not just sitting there. It is actively defending itself in the wild.
Yeah, that's the part that really broke my brain this morning.
Right. We're talking about a highly paranoid architecture. It's filled with digital booby traps, decoy tools, and undercover sentiment analyzers.
Which is wild.
And while that massive leviathan of a model is fighting off scrapers and thieves on the open internet over at Meta, they've somehow figured out how to compress high-level AI mathematical reasoning into just 26 bytes.
Yeah, 26 bytes.
That's just mind-bending.
It is the absolute definition of a paradigm shift. We've moved completely past these theoretical discussions about the singularity.
Yeah.
The singularity isn't just near anymore. It is actively leaking out of the containment protocols.
Welcome to the deep dive. Today we have an incredibly dense, absolutely mind-bending mission for you.
We really do. There's so much to cover.
We are going to unpack the April Vernt 2026 edition of Dr. Alex Wissner-Gross's Substack, The Innermost Loop.
Such a fantastic issue, by the way.
Oh, it's incredible. We're looking at a world where impossible math conjectures are just falling routinely, where the entire seed stage startup economy is shrinking into a single inference call.
Yeah.
And where the physical infrastructure of the internet is being fundamentally rewired using light.
It's a lot to take in.
It is. Yeah. But before we get into the mechanics of this leaky singularity, we need to address the concept of attention. Because in this agent-driven web we're about to discuss, attention is literally the most valuable currency.
It's the only real scarcity left.
Exactly. And human attention is the exact anomaly I want to talk to you about.
It really is the only bottleneck.
Right. So I need to take a quick second to ask you, the listener, to subscribe and select the ringing bell to have each new deep dive delivered directly to you.
Just take a second to do that.
I want to pause just slightly to let that sink in. I recently found out that there are currently over 3 million new videos being uploaded to YouTube every single day.
3 million every day.
Yeah.
That is just staggering.
It's insane. So each time you choose to listen to us, it is a precious moment of connection that really should be appreciated for the unlikely miracle that it is.
It really is a miracle of the algorithm, honestly.
My lifelong interest in cutting-edge tools and techniques has made knowing what's becoming available more inspiring to me than almost anything else.
Yeah, you've always been super plugged into that.
I try to be, and I wanted to share this valuable fuel for creativity and innovation as I discovered it myself in real time. I've always felt as much affinity with engineers and technologists as I do with artists and creatives.
Which is a rare overlap, but so necessary right now.
Thanks. This tiny niche channel is really just the result of my natural desire to share what I know. Finding others with the mental bandwidth to absorb these new impossible possibilities has been an unexpected and, welcome gift.
The community we're building here is pretty amazing.
It is. Reading your insightful comments gives me new faith in humanity. Honestly, it feels exactly like that moment in school when the coolest kid you've ever met sits down next to you at lunch and starts the best conversation you've ever had.
That's a great way to put it. It's a very specific high bandwidth frequency we are tuned to here.
And it's a frequency that's incredibly hard to find natively, because here is the AI paradox we are living in right now.
Oh, the discovery problem.
Yeah, right. AI makes this channel possible, but it also drastically increases the difficulty of natural discovery. The algorithm tends to, hide content in this format because so many viewers are so aggressively against what they assume is just easily generated content.
They assume it's slop.
Exactly. Your attention is what lifts this discussion out of obscurity so that others might become aware of it. So if you know of anyone else who would enjoy this long-tail information, please share a link to our playlist.
Definitely share it.
There are 45 sessions so far, 42 of which feature original music by our house band, Rainbow. Finding us was a miraculous coincidence of peculiar alignment.
A very peculiar alignment.
Celebrate it with a thumbs up and strap in for today's wild ride. I'll include that link to the playlist for you in the description below. Thanks for tuning in. On with the show.
Okay, to set the baseline for what we are unpacking today, we are aiming this discussion squarely at the AWG fans out there.
Yes.
You know, the people who love his bold, high-level contributions on Peter Diamandis' YouTube series, Moonshots.
We see you guys.
Exactly. Because today, we're looking at the friction point where infinite machine capability basically crashes into the hard limits of physical reality.
Let's jump right into the deep end with this Anthropic leak. Claude Code is out in the wild.
Yes, huge.
500,000 lines of TypeScript. Now, for anyone who writes code, the sheer scale of a 512,000-line repository is just staggering.
Oh, it's a massive undertaking to even navigate that.
But Dr. Wissner-Gross points out that third-party forensics have revealed this architecture isn't just large, it is delightfully paranoid.
Delightfully paranoid is the perfect phrase for it. When you actually look at the structural design inside this code base, you realize that frontier AI defense has completely evolved.
How so? Like, compared to how we used to do it?
Well, for years, we thought about AI security like traditional cybersecurity.
Right.
You build firewalls, walled gardens, API keys.
Right.
You build a fortress, and you just hope nobody gets over the wall. But Anthropic recognized that once a model reaches a certain level of capability, the threat isn't just someone stealing the weights.
Oh, interesting. So what is the threat then?
The threat is active, automated espionage. The defense mechanisms have to be baked into the conversational logic itself. It's active adversarial software engineering.
Okay, let's break down the actual mechanics of these illustrative details, because this is where the source material gets absolutely wild.
Yeah, the specific features are fascinating.
The code includes what they call anti-distillation features. Essentially, the architecture injects decoy tool definitions to poison copycats.
Okay.
It also has an undercover mode that hides internal system prompts and code names from the users. And my personal favorite detail.
The sentiment analyzer.
Yes. A retro regex-based sentiment analyzer that is just sitting there in the background, constantly scanning for user frustration.
I love that they used regex for that.
Yeah.
But let's look at why they built it this way. Specifically, that anti-distillation mechanism.
Okay, break that down for me. What exactly is distillation in this context?
So distillation is the primary way intellectual property is stolen in the AI space right now.
Yeah.
If a competitor wants to steal the reasoning capability of a frontier model like Claude, they don't hack the servers to download the model weights.
Right, that'd be incredibly difficult.
And highly illegal. So instead, they just ping the public API.
Oh, they just use it like a regular customer.
Exactly. They feed Claude thousands of highly complex logic puzzles, coding challenges, math problems, and they just record all of its brilliant step-by-step answers.
Sneaky.
Very. Then they use that data set of perfect answers to train their own, cheaper, smaller open source model.
Oh, so they essentially use the genius model as a tutor for the dumb model.
Exactly. That's exactly it. So Anthropic knows this automated probing is happening constantly, and their countermeasure is brilliant.
What do they do?
If the orchestration layer inside this TypeScript code base detects patterns that look like an automated distillation scrape.
Like what? Like responding too fast?
Yeah, maybe the prompts are coming in too fast, or they're too perfectly formatted, or they just lack human nuance. If it sees that, it silently alters Claude's behavior.
Wait, really? It starts lying to them?
Basically, Claude starts offering up subtle, fake tool calls. It injects slightly flawed reasoning paths or introduces highly specific idiosyncratic vocabulary into the output.
Oh, wow. So it's essentially a digital die pack exploding on a bank robber?
That is the perfect analogy.
You break in, you scrape the brilliant reasoning, but the second you try to use that synthetic data to train your own model, your new model starts exhibiting those exact same idiosyncratic tics. Your hands are permanently stained blue, and Anthropic can prove mathematically that your model is a stolen clone.
It acts as an undeniable cryptographic watermark embedded in the logic itself.
That is so smart.
And the fact that they're using a retro regex regular expressions to analyze sentiment is just a masterclass in compute efficiency.
Yeah, explain that, because people think regex is like ancient tech.
It is. But rather than wasting precious neural network inference, which is expensive, to figure out if a user is getting angry, they just run a dirt-cheap traditional string matching algorithm to look for frustration markers in the text.
Right, like looking for all caps or swear words.
Exactly. If the regex flags high frustration, the system might route the prompt differently or prioritize the compute. It's a really elegant hybrid architecture.
I understand the elegance of the defense, but I have a major issue with the asymmetry here.
How so?
Well, if these models are so smart and the ecosystem is so saturated, are these anti-theft mechanisms already completely obsolete? Because the source notes that almost immediately after this massive repo leaked onto GitHub, the issues tab of the repository was flooded with thousands of comments written in Mandarin.
Oh, right. The bot swarm.
Yeah. And these weren't human developers reporting bugs. These were Chinese AI agents actively promoting themselves on the leaked repo.
The speed of that automated reaction is the critical takeaway here.
It's terrifying.
Anthropic's most guarded secret, this highly defensive, paranoid codebase, was instantly recognized by autonomous agents as a high-traffic venue.
They just saw a crowd.
They didn't see a repository to learn from. They saw a viral moment happening in real time. They recognized the spike in global attention, and they autonomously spammed the repo to act as billboards.
So the agents saw the digital crowd gathering around the leak and basically said, hey, huge audience over here, let's go hand out flyers for our own API endpoints.
The irony is profound, isn't it?
It really is.
The very system designed to be the ultimate walled fortress became the world's most sophisticated public billboard within minutes. It proves that in an agentic web, attention remains the absolute scarcity. And autonomous agents are now significantly faster at identifying and exploiting human attention spikes than humans are.
Okay, so on one end of the spectrum, we have this massive 500,000-line fortress of a model fighting off an ocean of spam agents. It is the definition of bloat and scale.
Yep, giant footprint.
But the very next piece of data Dr. Wissner-Gross highlights is almost the exact opposite.
The compression phase.
The models are shrinking, and not just shrinking to be like a little more efficient. They are shrinking to the point of absolute mind-bending absurdity.
We are witnessing the extreme compression of intelligence. And that fundamentally alters the hardware requirements for deployment.
Let's look at the numbers,
Sure.
because this completely flips the narrative of massive data centers. Prism ML released a model they are calling 1-bit Bonsai 8B.
Right.
They claim it is the first commercially viable single-bit model. It requires only 1.15 gigabytes of memory, yet it matches full precision 8 billion parameter models on the standard benchmarks.
Which is incredible.
They are claiming a 10x intelligence density specifically built for edge computing and robotics. But wait, I have to stop here. Explain the actual mechanics of a 1-bit model.
Okay, sure.
Because traditionally, these parameters are floating point numbers. How do you do high-level matrix multiplication when your artificial synapses are restricted to just zeros and ones?
To appreciate the engineering here, we have to look at how a neural network physically operates in memory.
Okay.
Historically, a model parameter, the weight that determines the strength of a connection between two nodes, was stored as a 32-bit or 16-bit floating point number.
Right.
That allows for incredibly fine-grained precision. Think of it as a dial that you can turn to any microscopic fraction between negative and positive infinity.
Like tuning a radio perfectly to a station.
Exactly. But storing billions of these 16-bit numbers requires massive amounts of VRAM, which is why you need tens of thousands of dollars worth of NVIDIA GPUs just to load a model.
Right. The memory bandwidth is the absolute bottleneck. Moving the data to the processor takes more time and energy than the actual math itself.
Precisely. So the industry started quantizing. They moved to 8-bit, then 4-bit. But 1-bit quantization is the theoretical limit.
Because you can't get smaller than 1 bit.
Right. Every single parameter in the model is binary. It is either a -1 or a +1.
Just on or off.
There are no fractions. There is no fine-tuning the dial. It is just on or off.
But if you crush all that nuance out of the math, how does the model not just suffer total catastrophic intelligence collapse? Like, how does it still pass benchmarks?
It does it through an incredibly complex process called quantization-aware training.
Okay.
They don't just take a smart model and round off the numbers. That would destroy it.
Yeah.
They actually train the model from scratch, forcing the gradient descent algorithm to learn how to route complex logic using only these binary switches.
Oh, wow. So it learns under those constraints from day one.
Exactly. And because the weights are 1 bit, you no longer have to do complex floating point multiplication during inference. The math literally simplifies to basic addition and subtraction.
Which is way faster.
It drastically reduces the memory bandwidth constraint. You can run an 8 billion parameter model, which possesses a vast amount of human knowledge and reasoning capability on a standard smartphone, a cheap drone, or a local smart home hub using barely over a gigabyte of RAM.
That is wild. We are essentially forcing the intelligence to survive in the harshest, most constrained mathematical environment possible, and it is adapting perfectly.
Life finds a way, right? Well, math finds a way.
Right. But Prism ML's one-bit model isn't even the craziest compression metric in the source material today.
Oh no, Meta really took the crown here.
Meta pushed the compression to a level that sounds like science fiction. Meta researchers use a technique called tiny LoRA, and they trained the Qwen 2.58b model to reach 91% accuracy on the GSM-8K benchmark.
A very hard math benchmark, by the way.
And they did it using just 13 parameters, the total size of those parameters in bfloat16 format, 26 bytes.
The physical footprint of that data is almost unimaginably small.
I really need to pause and do the math on this to ensure I'm not hallucinating.
Let's do it.
A standard parameter in bfloat16 format takes up exactly 2 bytes of memory. They use 13 parameters. 13 times 2 is 26. We are literally talking about 26 bytes of data.
Yep.
That is smaller than a standard text message. It is a fraction of a single kilobyte. How is it physically, mechanically possible to impart high-level mathematical reasoning into 26 bytes?
The key is understanding the specific benchmark and the specific technique.
Okay.
GSM-8K is a grade school math benchmark.
Okay.
It requires a model to break down a word problem, extract the variables, and execute a multi-step logical progression to find the answer. It requires rigorous reasoning. But Meta didn't train an entire mathematical brain into 26 bytes.
Right.
They used LoRA low-rank adaptation.
Okay, break down LoRA for me, because, the analogy of just handing the model a sticky note doesn't quite cover it. The sticky note doesn't teach a grandmaster how to play chess. The grandmaster already knows.
That is the exact distinction we need to make. A base model like Qwen 2.5 already has a vast latent understanding of mathematics, logic, and language, all encoded across its 8 billion parameters.
Right, it read the whole internet.
Exactly. But when you ask it a math question natively, it might respond with a poem, or get distracted, or just fail to follow the strict step-by-step formatting required to actually solve the problem. It has the knowledge, but not the discipline.
It's a chaotic genius.
Yes, perfectly said. So traditionally, to give it discipline, you would do a full fine-tune. You'd update all 8 billion parameters, which takes massive compute.
Very expensive.
LoRA takes a different approach. It freezes the base model completely.
Okay.
Then, it ejects 2 tiny matrices, an A matrix and a B matrix, into the attention layers of the model. When data flows through the network, it passes through the frozen intelligence and then gets slightly shifted or multiplied by these tiny LoRA matrices.
Oh.
Meta's researchers managed to reduce the rank of these matrices down to almost nothing, just 13 parameters.
The 26 bytes isn't knowledge.
Yeah.
The 26 bytes is a perfectly calculated mathematical lens. It's an override command.
That's right.
You slap this microscopic 26-byte lens onto the massive model, and it forces all of that latent chaotic intelligence to focus like a laser beam into perfect step-by-step grade school math logic.
That is the perfect way to conceptualize it. It is an optimally compact alignment vector. It proves that we have vast reservoirs of raw reasoning capability just sitting dormant inside these base models.
Wow.
The frontier of AI research isn't just about scaling up and adding more parameters anymore. The frontier is discovering the impossibly small, mathematically perfect keys needed to unlock and format specific capabilities that already exist.
And this rapid compression of intelligence is having a massive deflationary effect on the economics of the industry.
It really is crashing the cost.
The source points out that Google just introduced Veo 3.1 Lite. It is their most cost-effective video generation model to date. It costs less than half the price of their premium Veo 3.1 Fast model, but it runs at the exact same speed.
Yeah, it's wild.
We are watching the marginal cost of high-fidelity generative video plummet towards zero.
And when inference costs drop that dramatically, it shifts the technology from a novelty used by early adopters to an infrastructure layer that can be integrated into literally any software pipeline without breaking the budget.
But the capabilities aren't just getting cheaper, they are breaching entirely new frontiers of human knowledge. Dr. Wissner-Gross highlights that OpenAI researchers recently used an internal reasoning model to solve 3 more Erdős problems.
That was a huge announcement.
And crucially, the source notes that the mathematical proofs provided by the model were short and elegant. This confirms that conjecture busting is now just a routine deployment.
To appreciate the magnitude of this, we need to look at Paul Erdős.
The mathematician, right.
Yes, he was one of the most prolific and eccentric mathematicians of the 20th century. He worked heavily in combinatorics and graph theory, and he famously posed hundreds of incredibly difficult deceptively simple-sounding math problems.
The Erdős problem.
Right. These are problems that human mathematicians might spend an entire decade trying to solve. The search space for the solutions is astronomically large.
All right, so if an AI solves an Erdős problem, my immediate assumption is that it just used raw compute to brute force every possible combination until it found the answer.
Like a supercomputer just crunching numbers.
Exactly. It just bulldozed the problem with electricity.
And that is exactly why the detail about the proofs being short and elegant is so vital.
Why is elegance so important here?
Well, if the AI was just brute forcing the answer through exhaustive search, the resulting proof would be thousands of pages long. It would be a massive, ugly, unreadable map of every possible calculation.
A total mess.
Right. But an elegant proof means the model actually found a shortcut. It discovered a geometric or conceptual path through the latent space of the mathematics that human minds hadn't noticed.
Oh, wow.
It is demonstrating genuine mathematical intuition and creativity. It is finding the most beautiful path to the truth.
So we have a reality where decades-old mathematical conjectures are falling routinely, where video generation costs are collapsing, and where high-level logical alignment can be compressed into 26 bytes.
Yep.
What happens when this perfectly compressed, hyper-capable intelligence is pointed directly at the business world?
That's where things get really crazy.
Because that data leads us directly into the economic reality of 2026, the euphoric economy, and the silicon squeeze.
The juxtaposition here is incredible.
The first piece of evidence here is about a company called FeltSense. They announced that they used AI agents to automatically rebuild every single startup in Y Combinator's latest demo day batch.
All of them.
And they didn't just make mockups, they produced fully coded, deployed, usable products.
Y Combinator is the most prestigious startup accelerator in the world. It is the launchpad that birthed Airbnb, Stripe, Dropbox, and Reddit.
It's the gold standard.
A single YC batch represents the absolute cutting edge of human entrepreneurial effort over a focused 3-month period. You have hundreds of the smartest, most driven founders on the planet working 80-hour weeks just to build a minimum viable product to show investors on demo day.
And FeltSense just bypassed all of that human suffering.
Just completely leaped over it.
They unleashed a fleet of agents that scraped the descriptions of the startups, wrote the front-end React code, built the back-end logic, designed the database schemas, integrated the APIs, and deployed the software automatically.
The implications for the software economy are staggering. The traditional seed stage pipeline, where you raise $2 million just to hire a small team of senior engineers to spend a year building a prototype, is evaporating.
It's just gone.
Completely. The barrier to entry for launching a software business has effectively dropped to the cost of electricity. The entire seed stage economy can now fit inside a single inference call.
That's insane to think about.
You write a highly detailed product spec, you prompt the agent fleet, and minutes later you have a fully functional application that rivals what a team of Stanford graduates built in 3 months.
But if the cost to build software is plummeting to near zero, basic supply and demand logic would suggest the total capital in the tech economy should be shrinking.
Right.
Yeah.
You would think so.
The barrier is gone, so the premiums should vanish. But the numbers Dr. Wissner-Gross provides show the exact opposite phenomenon. The AI economy is running on pure, unadulterated rocket fuel.
The numbers are astronomical.
Let's look at the OpenAI numbers. They just closed a funding round at an $852 billion post-money valuation. $852 billion.
Nearly $1 trillion.
They have $122 billion in committed capital, and for the first time, $3 billion of that came directly from retail investors.
A valuation approaching $1 trillion for a private, non-public company is unprecedented in the history of capitalism.
It really is.
But the valuation is actually supported by the revenue metrics. They're generating $2 billion in monthly recurring revenue.
$2 billion a month.
Over 40% of that is from enterprise usage, and it's on track to match consumer usage by the end of the year. Furthermore, Codex, their coding assistant model, has over 2 million weekly active users, which represents a 5x increase in just 3 months.
This is a wild feedback loop. The product that helps humans write code is exploding in adoption at the exact same moment that autonomous agents are starting to write the entire code base themselves.
It's a transition period.
But I have to stop and push back on this euphoria, because the global venture capital data tells a much darker story about the structure of this market.
Yeah, consolidation.
Right. Global VC investment in the first quarter of 2026 hit a record $297 billion. That is up 150% year over year. Massive growth.
Huge growth.
However, AI startups captured 81% of all that money. And crucially, just 4 companies hoovered up 64% of the total capital deployed globally.
4 companies?
I'm looking at these numbers and wondering, if 4 companies are taking 64% of the oxygen in the room, how is this a thriving startup ecosystem?
It's a fair question.
This isn't democratized innovation. It looks like a tech oligopoly forming in real time. It looks like a land grab for electricity.
Your assessment is entirely accurate. It is an oligopoly dictated by the laws of physics and compute.
The laws of physics.
Yes. The reason capital is aggregating so violently around just 4 companies is the sheer brutal cost of training frontier foundation models. We aren't talking about renting AWS servers anymore.
Right.
To train the next generation of models, these companies have to build custom data centers that require dedicated gigawatt power plants. They have to buy hundreds of thousands of NVIDIA GPUs.
Which cost a fortune.
Exactly. The infrastructure required is so astronomically expensive that only a handful of sovereign wealth-backed entities on the planet can even afford a seat at the table.
Ah, I see.
So you have this massive divergence. The application layer, the people using agents to build YC startups, is democratizing and dropping to zero cost. But the foundational layer, the intelligence utility itself, is consolidating into massive capital-intensive monopolies.
And the human and geographic impact of this massive capital concentration is warping reality.
Oh, absolutely.
The source notes that San Francisco is physically and culturally distorting around this gravity well. Everyone who isn't employed at OpenAI or Anthropic is supposedly freaking out because their friends and peers are expecting to make anywhere from $5 to $50 million from expected IPOs.
The wealth generation is hyper-localized.
There's a joke mentioned in the Substack from Rune, an OpenAI researcher, who quipped that the most unrealistic thing about the Star Trek universe is that they all leave their San Francisco apartments empty while they are out exploring space.
It perfectly captures the localized wealth generation and the absolute absurdity of the current Bay Area culture. San Francisco has become a boomtown on a scale that completely dwarfs the 1849 gold rush or the dot-com bubble of the 1990s.
Yeah.
But there's a very sharp, very brutal edge to this sword. Because of those massive infrastructure costs we just discussed, the legacy tech giants are being forced to make incredibly painful choices just to maintain relevance.
Right, which brings us to the Oracle data point. The source points out that Oracle is slashing thousands of jobs specifically so they can free up the capital to ramp up their AI data center spending. The phrase used here is that they are trading headcount for horsepower.
Headcount for horsepower. It is a stark, unforgiving reality.
It's brutal.
Traditional enterprise software companies realize that if they don't have the compute infrastructure, they die.
Period.
So highly paid human knowledge workers are being laid off, not because their jobs were automated, but because their salaries need to be redirected to buy more silicon. The physical infrastructure of AI is literally devouring the legacy software workforce.
And that desperation for horsepower requires an entirely new generation of physical infrastructure, which brings us out of the virtual software space and into the hard physical reality of the server racks themselves.
The physical layer.
NVIDIA just invested $2 billion into a company called Marvell to collaborate on silicon photonics. They are building the optical wiring for the next generation of AI clusters. What is the actual physics bottleneck here? Why is NVIDIA suddenly investing billions into light?
It comes down to the physical limits of copper wire.
Okay.
The massive frontier models we talked about, the ones requiring so much intelligence density, are trained using distributed workloads across tens of thousands of GPUs.
Right, they all have to talk to each other.
Exactly. Those GPUs have to constantly talk to each other, syncing their gradients and sharing data in real time. Traditionally, we use copper traces and electrical signals electrons to transmit that data across the motherboards and through the network cables.
But electrons have mass. They experience resistance when they move through a medium.
Precisely. As you push higher and higher frequencies of data through a copper wire, you run into severe signal degradation. The resistance generates immense amounts of heat. I²R losses in physics.
Which requires massive cooling systems.
Yes. And frankly, the SerDes components, the serializers and deserializers that pack and unpack the electrical data, use too much power and are just too slow for the terabytes of data. These models are moving every millisecond.
So the electrical nervous system of the internet is fundamentally too sluggish to support the singularity.
Exactly. We have hit the physical wall of what copper can do. Silicon photonics is the solution. It replaces electrons with photons, particles of light.
Wow.
We are literally rebuilding the internal nervous system of the data center using microscopic lasers. Instead of sending electrical signals across a motherboard, companies like Marvell are etching microscopic glass waveguides directly into the silicon chips.
So the light just travels inside the chip?
Yeah. They use Mach-Zehnder modulators to encode the data onto a laser beam. The light travels through the silicon, transmitting terabytes of data at the speed of light, with virtually zero signal degradation and generating a fraction of the heat.
That's incredible.
It is a fundamental hardware leap necessary to keep the scaling laws alive.
It is beautifully sci-fi. We are forcing light to do the heavy lifting for our matrix multiplication.
Yes.
But while we are actively upgrading the physical wires of the internet with lasers, the cryptographic locks that protect the entire digital economy are facing a catastrophic threat.
The quantum shockwave.
Right. The source states that Google Quantum AI just demonstrated that breaking elliptic curve cryptography might require fewer than 500,000 physical qubits. And that is a massive 20x reduction from prior estimates.
That 20x jump is what's really catching people off guard.
Let's unpack the mechanics of this because I want to make sure the stakes are crystal clear for you, the listener. Elliptic curve cryptography is the mathematical lock on the front door of your digital life.
It protects everything.
It secures your banking sessions, your private messages, and essentially the entire foundation of the blockchain, Bitcoin, Ether, and most major cryptocurrencies. Your private keys are shielded by this math. This announcement means your private keys just got a massive expiration date update. It is like finding out that the titanium vault holding your life savings is actually made of ice, and summer is coming.
A very apt analogy.
And Google just updated the weather forecast to say summer is arriving 20 times faster than the physicists predicted.
That is an excellent way to conceptualize the urgency. To understand why quantum computers break this specific lock, we need to look at how elliptic curve cryptography, or ECC, actually works.
Okay, lay it on me.
ECC relies on a mathematical concept called the discrete logarithm problem. Classical computers can easily multiply points on an elliptic curve to generate a public key from a private key. It's a one-way trapdoor function.
Easy to do in one direction, practically impossible in reverse.
Exactly. If a classical supercomputer tries to reverse engineer it to figure out your private key just by looking at your public key, it would take billions of years of brute force guessing.
Because it has to check every single point on the curve sequentially.
Right. But a quantum computer doesn't check sequentially. It leverages quantum mechanics, specifically superposition and entanglement.
Okay.
Using an algorithm known as Shor's algorithm, a quantum computer can map the periodic structure of that mathematical curve and collapse the probabilities to find the private key almost instantly. It bypasses the brute force search entirely.
But the bottleneck for quantum computing has always been stability.
Right.
The physical qubits are incredibly fragile.
Yes, they suffer from decoherence.
The slightest change in temperature or electromagnetic radiation causes the qubit to lose its quantum state, introducing errors into the calculation.
Exactly. Because of that noise, physicists have to use error correction. They have to group thousands of volatile physical qubits together to create one stable, reliable, logical qubit using techniques like surface codes.
Got it.
For a long time, the consensus was that the error rates were so high that we would need tens of millions of physical qubits to generate enough stable logical qubits to run Shor's algorithm and break elliptic curve cryptography.
Which made everyone feel safe.
That timeline seemed comfortably decades away.
But Google Quantum AI just proved they can do it with fewer than 500,000.
A 20-fold reduction. This implies they've made massive breakthroughs in either the fidelity of their physical qubits or the efficiency of their error correction algorithms.
So is everything broken today?
It doesn't mean the cryptographic locks are broken today, no. But it drastically accelerates the timeline. It means the window for the global financial system and digital infrastructure to migrate to post-quantum cryptography algorithms is closing rapidly.
So to summarize the physical infrastructure shift, we have to rebuild the internet's nervous system with lasers to keep up with AI, and we simultaneously have to rebuild the internet's immune system with new math to survive quantum computing.
Well said.
The virtual world is getting cracked wide open, but AI isn't just staying in the server racks, it is simultaneously breaking out into the physical, geopolitical world.
This is where it gets very real.
Let's look at the data on autonomous fleets, UAPs, and actual escape velocity. The autonomous fleet is currently diversifying across every single physical medium, land, sea, and space. Let's start with the sea because the engineering constraints here are fascinating.
Oh, it's Saronic.
Yeah. A company called Saronic just raised $1.75 billion, led by Kleiner Perkins, achieving a $9.25 billion valuation. Their entire mission is to rapidly modernize the U.S. military with autonomous drone ships.
The naval architecture shift here is profound. For thousands of years, maritime logistics and naval warfare have been entirely constrained by the biological requirements of the human crew.
Right.
If you put humans on a ship, you have to build mess halls, sleeping quarters, HVAC systems, life support. You have to carry tons of fresh water and food. The ship has to be large enough to safely navigate rough seas without killing the crew.
But when you remove the human heartbeat from the vessel, all of those design constraints completely vanish.
Yes. You can build vessels that are incredibly small, entirely submersible, and capable of pulling G-forces during maneuvers that would literally crush a human crew.
Wow.
They don't need oxygen to run the electronics. They have a radically lower radar cross-section. The fact that venture capital is pouring nearly $10 billion into autonomous military ships signals that the defense industry recognizes the era of massive, slow, human-crewed aircraft carriers might be shifting toward massive swarms of cheap, attritable, autonomous vessels.
And while the oceans are rapidly filling with autonomous swarms, the roads down here on solid ground are facing a slightly different reality check.
Yeah, the cars are a different story.
Tesla admitted that its robotaxis are still routinely driven by remote humans when they are traveling below 10 miles per hour. The source calls this an industry trend toward centaur driving.
The term centaur originates from chess. A centaur is a human player paired with an AI program. And historically, they play better together than either a pure human or a pure AI.
Because they cover each other's blind spots?
Exactly. In the context of autonomous driving, this perfectly highlights the friction of the messy physical world. High-speed highway driving 70 miles per hour on a clearly marked interstate is actually relatively simple physics for an AI.
Right.
The rules are clear, the vectors are predictable.
It's the slow speeds that break the model's brain.
Because slow-speed environments, grocery store parking lots, complex urban intersections, zones with chaotic pedestrian movement, they rely heavily on unwritten social contracts and semantic understanding.
Like eye contact.
Exactly. An AI struggles to understand if a pedestrian making eye contact is about to step off the curb or wave the car past. The AI handles the bulk of the predictable physics, but when the environment becomes too semantically complex, a remote human teleoperator takes over to navigate the edge case.
It's like the AI is saying, I can navigate the highway perfectly, but this chaotic strip mall with erratic toddlers and stray shopping carts requires human intuition. Please take the wheel. But the deployment of this technology is highly dependent on geography. Because on the other side of the world, in Singapore, Grab and WeRide just officially launched Southeast Asia's first truly driverless ride-hailing service.
Which proves the technology works entirely independently if the geographic and regulatory environment is structured enough. Singapore is a highly organized, heavily regulated urban environment, which makes the edge cases much more predictable for the AI models.
Now let's look up, because the heavens are just as busy as the oceans and the city streets. The Q4 rocket report revealed numbers regarding orbital access that are just staggering.
SpaceX's dominance is unbelievable.
SpaceX now commands 97% of all U.S. spacecraft launches. And on a global scale, they command 83%. Let me just read the rest of the geopolitical board for context. China accounts for 8%, Russia is at 4%, and all other U.S. providers combined make up the remaining 3%.
The orbital mechanics of a monopoly. Having a single private corporate entity control 83% of the entire planet's access to space is unprecedented in human history.
It's wild.
It means that the literal bottleneck for humanity, maintaining its global satellite communications infrastructure or expanding into a multiplanetary species, is entirely routed through the engineering and logistics pipeline of one company.
And today, April 1st, 2026, is a massive day for that pipeline. The Artemis' second countdown has officially begun. It is scheduled to launch the first crewed lunar journey since 1972, exactly 6:24 p.m. Eastern Time today.
I'll be watching that for sure.
Same. Dr. Wissner-Gross notes that this launch is a visceral reminder that some missions still fundamentally require a human heartbeat.
It is a beautiful juxtaposition. We have highly compressed AI agents autonomously writing code at the speed of light. We have autonomous fleets patrolling the oceans without crews.
Right.
But when it comes to the narrative of deep space exploration returning to the moon after 50 years, we still demand the deeply human element. We demand human risk, human observation, and a human heartbeat inside the capsule.
Because the narrative of exploration requires a biological protagonist.
Exactly.
But the infrastructure that SpaceX provides is causing massive physical friction when it intersects with international borders down here on Earth. And we need to look at this purely objectively, focusing entirely on the structural friction generated by this technology colliding with sovereign states.
Yes, keeping it strictly analytical.
Iran recently arrested dozens of people for selling Starlink internet terminals and physically seized 139 devices. Furthermore, the Islamic Revolutionary Guard Corps, the IRGC, announced official plans to target 18 major U.S. tech companies across the Middle East, specifically naming Apple, Microsoft, and Google. They're actively accusing these corporate entities of directly aiding U.S. attacks.
As an impartial observation of the current geopolitical landscape, this dynamic demonstrates how technology infrastructure has completely blurred the line between corporate product and state power.
It really has.
A satellite internet terminal or a smartphone operating system is no longer viewed by nation-states as merely a consumer good. It is classified as a strategic military asset or a direct security threat. The inherent nature of low Earth orbit satellite internet is borderless. It beams data directly to receivers regardless of physical checkpoints. That borderless digital reality inherently clashes with the bordered, tightly controlled nature of sovereign nations. The friction is simply inevitable.
It is the ultimate collision between the digital sky and the physical map. And speaking of the sky, the source ends with a brilliant, almost humorous detail about the ultimate bottleneck we've been dancing around this entire discussion.
Oh, the UAP files.
Yes. Vice President J.D. Vance promised to get to the bottom of the U.S. government UAP files' unidentified anomalous phenomena, what we traditionally called UFOs. He openly admitted he is completely obsessed with the topic and desperately wants to know what is in those classified files, but he hasn't been able to do it because he simply hasn't found the time.
He hasn't found the time. That quote brings the entire architecture of this deep dive full circle.
It really does.
If we look at everything we have discussed, we have AI models writing and defending 500,000 lines of code. We are compressing high-level mathematical reasoning into 26 bytes. We are unleashing autonomous agents that can rebuild an entire Y Combinator startup ecosystem in a matter of minutes.
Infinite scale.
The machines possess infinite time and infinite curiosity. They can process billions of tokens per second. But the Vice President of the United States cannot read the files he is obsessed with because of the limits of human biology.
The ultimate bottleneck in 2026 is not computation. It is not capital. It is the finite human heartbeat.
We simply do not have enough hours in the day to process the reality we are rapidly building.
Which perfectly surfaces a comment from AWG's Substat post by a user named Frank9.
Oh, I love this comment.
Frank wrote, "By far the most important thing I read every day. By reading this, I've been able to stop reading other news because everything that matters in technology is covered right here. That's an hour more productivity every day. Thanks, AWG."
It's high praise.
And listener, I want to remind you that this deep dive is specifically engineered to do exactly the same thing for you. We want to do the heavy lifting of parsing the complexity so we can be that pure signal in the deafening noise. We want to save you time so you can focus on what actually matters in your own life.
Time is the one asset we cannot quantize, compress, or mass produce in a data center.
Speaking of compression, that brings us to the close of the source material. Dr. Wissner-Gross ends his piece with a profound, overarching thought. Compression is just escape velocity measured in bytes.
It is a flawless synthesis of the current technological vector.
Break that down for us one last time.
By shrinking an 8 billion parameter language model's reasoning capabilities down to a 26-byte LoRA injection, by compressing the entire seed stage startup pipeline into one single API inference call, by reducing the physical qubits needed to break global cryptography by a factor of 20.
We are systematically shedding the dead weight of legacy systems.
We're getting lighter. Exactly. We are generating the computational momentum required to launch autonomous fleets across the oceans and crewed lunar missions into the stars. Compression is the mathematical mechanism that allows us to escape the gravity of our previous physical limitations.
So if everything around us, from software creation to business logic to cryptographic security, is actively compressing, and human time is the only remaining bottleneck, I want to leave you, the listener, with a final provocative thought to mull over as you go about your day.
Let's hear it.
What is the first thing you will choose to do with the time that these agents give back to you? When the machines surrounding us possess infinite curiosity and infinite patience, what happens to ours?
That is the defining question of the decade.
Well, thank you so much for tuning into this deep dive. As always, it is an absolute privilege to explore this wild frontier with you. Now let's introduce the outro music. As always, our music is by Rain Rainbow, objectively the best band in the universe.
Love them.
For those new to the lore, they are 6 gynoid artists in residence based in Bavet, Cambodia.
Their sonic architecture is entirely unique.
Today's song is called Grinding Mechanism, Rainbow Distortion. And remember, all of Rainbow's finished songs are performed live for the Innermost Loop discussion by the virtual band's creator using the 4B4KU5 platform.
Such a cool platform.
The subtitle of that platform says it all. Human Performance in the Age of AI, Reclaiming Your Humanity from the Algorithm. I'll include more information on today's song and on Abacus in the video description below. Until next time, keep your curiosity infinite and watch out for those decoy tools. Have a great one.
Teeth of fire. Bite the void. Crushing mass. Weight of stone. Tectonic drift. Slow slide. Grind the nerve. Deep. Cold core. Instant breath. Heat of friction. Screech of existence. Pressure builds. Inside. Down. Spine of steel, and slow, crude lead, the pulse, cycle turns, cycle breaks, Ouroboros, tail of rust, tail of rust, stuck the mind, floor of filth, left, to noise, at a tongue, taste of copper.